Assalamualaikum and good day to all the listener. Okay, my name is Muhammad Mirza Azrai bin Abdul Zakir with the student number 2021269182. Today I will present regarding our my master studies entitled Single Stage Model Updating of a Bridge Structure for Structure Health Monitoring, which have been supervised by TS Dr. Muhammad Azhan Anwar, and the co-supervisor is Dr. Abdul Malik Abdul Wahab, and also TS Dr. Adiza Jamadin. As a brief introductions, in the recent years, vibrations has become one of the vital aspects that must be considered in many mechanical and civil problems. An engineer or vibration practitioner will only can interpret or identify the data after the vibrations measurements is conducted. The dynamic characteristics consist of a natural frequencies, damping ratios, and mode shapes, and basically all the material structures, components, and mechanical systems have a dynamic characteristics which needs us to understand to give solutions and the way forwards. In actual practice, studying and extracting the dynamic characteristic will consume many time due to its complicated process in preparing the hardware inside and updating the model to ensure the results will indicate uh, and represent the subjects of the real conditions. Engineers kept updating their results with the various methods which attributes a complicated work procedure. So the next is on the problem statements of the study. Okay, there are three factors that we have identified, which is first is time consumptions. Okay, the process to update the model requires a lengthy procedures and need more times to settle it. And second is a limitations. Usual model data extractions cannot access the information at the location without the sensor placements, and it is very good when we can get the unmeasured location without using a huge number of sensor. And lastly is a reliability of the data. Okay, the model updating for actual cases which is at site is usually complex and it need more accurate model for analysis. There are four research questions that I outlined on in my study. Okay, first is what is the procedure and steps of a single stage updating. Second, where and when single stage updating can be implemented. Third, how much the rate of validity when updating using a local correspondent principles. And lastly, does the single stage updating have an impact to the structural health monitoring fields of study? So I will answer it and I will explain it in my thesis uh, after the studies was done. The objective of the study which is have a three objective. Okay, first is to analyze experimentals and numerical dynamic characteristics of a UHPC bridge, such as the natural frequency and mode shape using OMA algorithm and FEA respectively. Okay, second is to perform a model updating using a local correspondence principles and a single stage approach based on the OMA data at the Sungai Raya UHPC bridge. And lastly, to verify and compare the degree of a consistency between OMA and FE mode shapes using a MAC value for each cases. Okay, the cases is before updating, after the LC expanded test, and lastly after LC expanded and a single stage. Okay, next is the scope of study. Okay, in this study, the work is not based on the finite element model updating, but on the mode shape correspondent. Okay, this research focus on implementing a model updating using a local correspondence principles with a single stage approach. and the dynamic characteristic determination will involve in experimentally and numerically. The experimentally is basically of, uh, starting on the post processing. Okay, and the subject will be referred to the Sungai Raya UHPC bridge at Kinta Perak. Okay, experimental raw data is already acquired, but it need to be extracted and analyzed back instead of taking the established result. Okay, so basically our experimentals will start on the post processing. Okay, experimental work will not take place in this study. Okay, the scope is more to prove the single stage approach as a new solution to the industry. Okay, next is on the literature review. Okay, the first literature reviews that I categorize is a model identification practice for a bridge. Okay, as Ginsburg said that model identifications was used over past 5 decades in the area of model updating, damage detections, substructure coupling, SHM, and also for the bridge. Okay, but OMA is still a rare method for the model identifications approach in Malaysia. Okay, as said by Abdul Ghaffar, Siringoringos, as well as Ivanovic. Okay, and secondly is experimental model analysis. Okay, as we know, and said by A. Calvi, IMA is progressive use since the introductions of digital FFTs in 1970s, but there IMA methods is still have a difficulties on exciting the desired low frequencies modes with adequate energies in the control conditions, and it's the major problems of these methods. Okay, according to the Boswell, because of the deficiency of experimental model analysis, uh, researchers are more enthusiastic about the non-destructive methods. So the operational model analysis introduced, okay, which it is only requires the structure response. According to the rule breaker, operational model analysis is convenient for more of the case since it is used the vibration data while the structure is in operations. Okay, last but not least, uh, model updating. Model updating is basically the process of altering the numerical values of individual parameters in the mathematical models. Okay, so that the models can represent the actual condition. Okay, according to the Sao Lond. Okay, and recently there are methods known as a single stage updating, which is it will mixing the matrix with the combinations of a local corresponding principles expansion technique, according to the Rumbrinker. The last points of my literature review is SHM in industries. Okay, according to the C. Farrar, the damage was not restricted to sudden impact and total loss of system functionality, but instead referred to when the system was no longer performing at its best. And according to the A. Scarf, SHM is a broad mature field that offers a practical implementations to evaluate the structure system. Okay, SHMs cover the machines, condition monitorings, global monitorings of the large structures, extensive area monitoring, and of course, local monitorings to be specifically. Okay, so now is on the general methodology. Okay, actually, this is my new methodology change compared to the previous methodology. Okay, I have been categorized it into the 3 phases. Okay, and the phase 1 will achieve the objective 1, phase 2 will achieve the objective 2, and phase 3 will achieve the objective 3. Okay, in the phase 1, I will extract the experimental data from the OMA, which involve only the post processing. Okay, and next, the development of the bridge model using the abacus, and run the model analysis to get the numerical result lah. Okay, and the experimental data will be compared to the numerical data, and I will get the result 1. Okay, from the result ones, we can use it in a phase 2. Okay, phase 2, the algorithm coding and the developments using the MATLAB uh, uh, will be take place. Okay. Next is smoothing and expanding of experimental mode shapes. Then fitting the smoothed and expanded mode shape into a numerical mode shapes. And lastly, fitted mode shapes are identified. Okay, so after the fitted process has been done, it will be compared to the experimental mode shape again, and I will get the result number 2. Okay, so the result number 2 will be used in the phase 3. Okay, so same as a phase 2, the algorithm coding and development using MATLABs. Okay, and I will implement a single step approach. Okay, so same again, I will compare the result from the single step approach to respect to the result from the experimental data, and I will get the result number 3. Okay, and lastly, I will compare, verify and evaluate all the results, result number 2, ones, number 2 and number 3. So I will conclude and prove the effectiveness of the single stage approach compared to the previous or uh, the other method. Okay, next is on the data collections. Okay, as now the data that I get is on its material properties for the USBC bridge. Okay, so the material properties that I've been search is for USBC concrete, okay, and deck and steel, okay, and the bridge dimensions, okay, as built drawing. So fortunately, this is my uh, latest update. Okay, the 3D models has been modeled in abacus. Okay, so there are three main parts in this model. Okay, first is the deck. Second, on the between is the internal girder, and the most right is the outer girder. Okay, so at the bottom is the full and a complete models for the bridge. Okay, the planning for the next semester. Okay, first I will run the numerical analysis using abacus to get the numerical results, and basically it will settle the phase 1. And second, develop the coding for a local corresponding principles algorithm in the MATLAB and run a single stage approach. And third, more in-depth research toward the effectiveness of SCP methods on OMA. So basically, the point number 2 and 3 will carry the phase 2 and 3 respect to the its objective. So the publications, currently I have been published one paper on the IEEE explore and the scopus. Okay, basically it is about the lab cases for me to identify and foresee the idea of a model updating in a designated conditions. Okay, it was involve a three-story building models, which consists of three plates, four bars, and 32 brackets. Okay, and all the lowest brackets were clamped at the base, and the material made of aluminiums, and overall dimensions is about 850 mm times 250 mm times 250 mm. Okay, so the details you guys can get from my papers, and just click the links and find the more details on the results. So as the progress of my study, uh, currently I was on the coding and development for the SCP algorithms. Okay, so it will end on the September, and on the September onwards I will start on the model updating using the LCP method. So that means the end of my presentations. Thank you for lending your ears, and for any question of inquiries, just contact me on the email below. Thank you very much.